Mean, median, and mode are three different measures of central tendency. Central tendency is the ultimate in data reduction. You can take an entire data set. There are two data sets in front of you, set number 1 and set number 2. They're pretty limited in size, but you can have any size data set. You can have tens of thousands of individual measurements in a data set, and central tendency reduces that to a single number, which is supposed to represent, as best as it can, the entire data set. And the way you calculate these will be shown in this video. The three different measures are the mean, median, and mode. Now, the mode is, oops, go back a little bit. The mode is relatively straightforward when given the original data set, as we have in these two cases. You just have to look through and see which number happens the most frequently. In this case, it looks like the 13s. There are 3 13s. No other number occurs more than 3 times. So in this case, mode is 13. And if we look over at data set number 2, the mode, we scan through, and it looks like 26 happens the most often. Now, when you calculate the mean is what most people consider to be the average. Now, the term average actually can apply to all three terms. Now, mode is average, mean is average, and median is also average. So average is actually a generic term. More specific would be using one of the mean, median, or mode terms. But to find the mean, that's when you add up the each individual measurement, or add up your data. In this case, in data set number 1, this adds up to 113 if you were to add it all up. And then you have to count how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so what you're going to have is the mean is going to be 113 divided by 11, which is equal to 10.27. So while 13 is the mode, 10.27 is the mean. And again, you can come over here, do the same thing with data set number 2. This turns out to be 336 if you add it all together, which means the mean would be 336 divided by, and you count up all the numbers, and in this case it turns out to be 12. And this average is 28. The mean is 28, where the mode is 26. You can see there's differences. Then, these numbers are supposed to represent the entire data set. Now, the last one is the mean. The median. Now, the median is the geographic center, of the data set. So you, first of all, have to make sure the data set is in numeric order, either ascending or descending will work. And you have to figure out where the middle is. And that's actually why I have two different data sets, because the mode and the mean are calculated pretty much the same in both of these, but the median is actually a little bit different. As we said, the number of numbers here, which we'll use n to represent the number of numbers, is 11. Where over here, there are 12 numbers in this data list. So you can actually do this visually with these two data sets because they're relatively small, but you can imagine if you have 872 measurements in your data set, it's a little hard to do that visually. So we need an arithmetic way of doing this. You want to find the middle. Of course, you can divide by 2, which 11 divided by 2 is, of course, 5.5. Now, there is no 5.5 number. There's a fifth number, and there's a sixth number, but there's no position which is halfway between. So what you can do is start knocking off from both sides. So, and start working your way in. And we can figure out what this 5.5 means. All right, we're going down symmetrically. All right, and so we have found the middle of the list. Well, what position is this? 1, 2, 3, 4, 5. This is the 6th position. So whenever you get a decimal number, what that means is we have an odd numbered list. There are 11 in this list, which is an odd number. So it's going to be, if you divide by half, you're going to get a decimal. You essentially round up, right, to the 6th. So if we had, 873 measurements in our data list, you would divide that in half, get a 0.5, and then round up to the next whole number. It's a little bit different when we have an even numbered list. Right? If we have 12 divided by 2, that's 6. Well, if we do the same routine and work our way towards the middle from the two ends, we can see that when we get to the middle, all of a sudden there isn't a single middle number the way there was in this odd numbered list. With an even numbered list, there's a middle pair, right? And let's look at this. 1, 2, 3, 4, 5. It's the 6th number and the 7th number are the pair. So a good rule of thumb with this stuff is when you divide by 2, you always go up. If it's a decimal, like 5.5, it becomes a single number 6. If it's an even numbered list and you get a whole number 6, then it's that number plus the one above it, 7. So again, if you have a large data set, 654, which is an even number, you'll get a whole number, and it'll be that plus the next one will be the pair. And to actually calculate the median, in this case, you're going to have to, and it sounds a little contradictory because you're using one of the other measures, essentially find the mean of the middle pair. And so in this case, the median would be 27.5. So when you have an even numbered list, the median isn't necessarily one of the numbers in the list. It's actually a between number. But you can actually see over here in an odd numbered list, the median is actually one of the numbers. Right? 12, right? It'll be one of the numbers in the list. The mode will be one of the numbers of the list. Again, the mean is not necessarily one of the numbers in the list. 10.27 isn't one of the numbers in the data set. So that's how you calculate mean, median, and mode from an original data list. If you're given a frequency table, that will be a little different.